So welcome to this case study on using classes within Python. During this tutorial, we'll play hangman. So here's what you'll learn. We'll start at the end, so I'll show you a complete working system for playing hangman, and we'll recreate that for the rest of the tutorial. So we'll start by setting the scene. So for example, I'll show you why I made the decision not to include a fancy user interface, and I'll also show you about displaying message boxes on screen. We'll then go on to look at enumerations. I don't think I've covered these in any other tutorials, and we will be using those during this one. We'll then look at writing your algorithm. It's often called pseudo-code. Until you can work out exactly what you're trying to do and the logical steps involved, you've very little chance of writing a program to solve it. We'll then go on to look at designing your classes. So there'll be two. There'll be a game and a guest class, and I'll look at the mental processes I went through while considering which properties and which methods to assign to each. Then we'll start writing the program. So we'll start the game. You'll validate your guesses to make sure users have typed in correct sensible letters, and then see whether the guesses are actually correct or not by marking them, whether they exist in the hangman word. We'll show a progress message on screen so the user can see how far they've gone and how far they have still to go and how many guesses they have left too. And then we'll test for whether the game's actually been won or lost each time around the loop. And finally, we'll test the final program. So I'll show you a bit about debugging classes in this particular stage. Now, at any point in your screen on most versions of this tutorial anyway, an icon should appear at the top right, and you should be able to click on that to see any files or exercises to do with this tutorial. But I think that's enough for listening to me. I'm going to hand over to Sven now, and he will guide you through the rest of this tutorial as always. So let's get started. You can't write a game of hangman until you understand the rules. What I've got here is a file called hangmancomplete.py. You can download this from the web page for this tutorial on our website, and it gives you the complete code which we're going to work towards building over the course of this tutorial. Embedded within it, on line 201 as it happens, is instruction to begin a game of hangman. The word I'm going to ask you to guess is ladder, and I'll give you just 5 guesses. There's no attempt to draw a scaffold, we'll come to that point in a second, and also I'm not going to use code runner, and again I'll explain why in a second. But for the moment, let's just run that. So if I press Ctrl F5, it tells me what I need to do. I need to guess a 6-letter word, and I can have up to 5 wrong guesses, and it wishes me good luck. So my first guess next letter, is going to be a D. And when I press return, it's good news. The letter D does appear, it fills it in my word for me, and maintains a list of all the letters I've guessed correctly so far, and tells me I've still got 5 of 5 guesses left. I'm not feeling so lucky now. I'm going to go for a W. I don't think there is one of those. And if I press return, you can see it tells me I've only got 4 of 5 guesses left. I'm going to continue to guess badly with a Q, and it's maintaining a list of all the letters I've guessed incorrectly as well. And I can continue along this. Let's try an L. There is one of those, so it fills it in for me. I'll guess an R. There's one of those, and at this point it looks like I'm going to guess the letter. Guess the word, rather. But actually, I'm not. So I'm guessing loads of wrong letters here, and when I eventually finish, it tells me I've used up all my guesses, and tells me what the word was, and tells me commiserations in the title. Finally, it gives me a message, and this is an important point about the whole tutorial. You can write classes in many different ways. The code you're going to learn now is by no means the optimal way of writing hangman. It's possibly a good optimal way to do it if you're teaching people through a tutorial on how to play hangman using classes in Python. But there's many different ways to skin a cat, as they say in an old English expression, and what you're about to see is just one of them. So just before we begin thinking about classes, I need to just set the scene. There's 3 things I want to briefly consider. The user interface we're going to use, which I think you'll probably agree was quite primitive. We'll look at how you can display message boxes to make it a bit livelier, and we'll look at why I'm not using code runner. So to do that, let's start with the first one, the user interface. I've included on our website the file tkinterexample.py, and what I'm going to do is just run that program without further ado. And when you do that, what you'll see is it comes up with a dating agency form, and you can type in your name. So you could type in Sven. About myself, I am Swedish. And then I can choose OK. And what it will do is display a quick summary of it. Now, the point of showing you this is that if I was going to write a proper Hangman game, I would probably use a GUI graphic user interface program like tkinter. The reason I'm not doing that and I'm relying on doing everything at the command prompt is because A, I don't like tkinter. I find it very cumbersome to use. And B, if we did this, I would spend a lot of time explaining how to draw the screen. And what I want to do is concentrate on the classes. So that's why I'm not using a glossy user interface. Now, to make it slightly more interesting, we're going to use message boxes. So what I'm going to start by doing is copying lines 8 to 15 to a new file called hangman.py. Let's get rid of that. And what this does is imports an external or internal rather module, a built-in module called ctypes, and uses it to display a message. And if you want to find more about the message box command in Python, you can go to the Stack Overflow article. So to show you how this works, what I could now do is display a message. So I could type in show message, and there's two arguments, which are the text to be displayed. So I think I'll say hello, and the title, which will be Wise Owl. And if I run this very modest little program, you can see it comes up and says hello owl. Hello, rather. So that will make it slightly more interesting. I can keep having pop-up messages rather than relying on using the terminal window all the time. The third thing I was going to show is why I'm relying on not code runner, but running using Control F5. If I go back to my program here and try running it with code runner by pressing Alt Control N, what it would do is take me to the output window, and I wouldn't be able to type anything in at the input prompt. So you can assume whenever I'm running this Hangman program that I'm pressing Control F5, the equivalent of run Python file. I think you can see that when you choose run from the menu up here, you can see there's two options. I'm going to choose run without debugging all the time. So it's important to remember to do that, otherwise you won't be able to type things in the terminal window. So with all that preamble out the way, let's look in more detail at our program. I've chosen in my program to use an enumeration to make it clear what the possible choices are for a status of a guess. And there are 5 choices I can think of. You can guess correctly, wrongly. You can already guess something, so you choose a letter which you've already previously guessed. It can be an invalid guess, so you either don't type anything in or you type in the string which is too long, or perhaps it's not even a letter. And it could not be set yet. Now, to make it clearer to work with these possible values, what I've done is created an enumeration. So what I'm going to do is copy lines 17 to 25 from the complete example into my code. I'll just get rid of that previous message. And then to show you briefly how this works, I think you can possibly guess already, I'm going to create a variable called status, which I'll get rid of in a moment, and I'll set it equal to guessStatus.correct. So what I can then do is test out the value of this status and say, if it equals, let's say if it's wrong, then what I'll do is print out that that's wrong. Otherwise, I'll print out that it's correct. And you won't be surprised to know that when I run this program, what it would do is display the word correct, and that's because I've set it to correct, so it doesn't equal wrong. To prove this works, let's just change that to wrong with one W, and if I run this time, it will give me the words wrong. So the benefit of this is when you have a discrete finite set of possible values for a particular status, for example, an enumeration makes your coding much easier clearer to read. So I could have put status equals 2 for wrong and checked if that equals 2, but then I would have been forever trying to work out what I meant by this number 2. So that's enumerations. The next stage in our programming process is to create an algorithm. And in any program, this is the most important thing. What you need to be able to do is to understand the task you've been given to do and to be able to turn it into a set of instructions which aren't quite English, but aren't quite Python either. Now, how you do this is up to you. Some people do it all in their head. Some people have a sheet of paper, which is my preference, and they write down very messy instructions on what they're going to do. The more experienced a programmer you are, the less you'll need to use a sheet of paper, because the more you kind of know where you're going to go anyway. This is my algorithm for solving the problem. And what I want you to do is think carefully as we go through it, whether you agree with it, whether you buy into it, and if so, we'll try turning this into Python. So the first thing you'll do is to start a new game, specifying the word to be guessed and how many guesses you're allowed, and then maybe show some instructions on how to proceed. What we'll then do is keep asking for guesses until the game is won or lost. So all of this code here, all of that, is going to be executed once for each guess that you make. And it's only when you break out of that code that you'll run the final bit of information or the final instruction to display a final message. So within that loop, what we're going to do is get the next letter to guess. So that's where we'll display an input box or an input prompt, and you'll type in a letter. You'll check if it's a valid guess, i.e. a single letter. And if it's not, just show an error message. Otherwise, so by the time we get to this point here, we know we've got a letter which we need to determine whether it's in the existing word or not, and whether actually we've guessed it previously. So what we'll do is try the guess out and get its status. And there are 3 possibilities. It's either correct, or it's wrong, or you've already guessed it previously. If you haven't already guessed it, what we'll do is display a message whether you've won or lost. We need to test whether you've completed the word or whether you've just run out of guesses. And you'll execute that each time around the loop. If you've either won or lost, the important thing is to break out of the loop. Without that instruction, you'll just carry on looping forever. And finally, by the time we get to this point, we know we haven't won and we haven't lost. So we'll display an update. And the update has to be quite detailed. It has to tell you what your last guess was, whether it was correct or not. It has to fill in how many letters you've got in the current word with underscores or blanks for the missing letters. It has to display the letters you've guessed correctly and the letters you've guessed incorrectly so far, and how many guesses remain to you. So that's my algorithm. Now, please don't think that I wrote that down from scratch. I didn't. I started writing the code. I realized many things. It took me quite a long time to realize that a guess has actually got 3 status. So it can be correct, it can be wrong, or it can be previously guessed. That took me a while. And basically, I went down a lot of wrong turnings. But I did start with a basic outline like this, which I tried to implement. Okay, it had flaws in the logic, but I did start with it. So what we're going to do now is to see if we can turn this pseudocode, as it's sometimes called, into Python. Now that we've got our algorithm and we know what we're trying to do, the next stage is to identify which classes we can create. Before we begin, can I just stress that there's no right answer to this. There's lots of different ways of approaching this. Some answers are more elegant than others. I'm not that satisfied with the one I've got, but I never am. I always think there could be a better way to achieve things with classes. So the first obvious class to identify in our problem is a game. You'll start a game, you'll stop a game when it's won or when it's lost, and each time in the game you'll offer up a different letter for consideration. The second obvious class is a guess. Each time you have a guess, it will consist of 1 or more letters, hopefully just 1 letter, and a status, whether that was correct, whether it was wrong, whether it didn't actually exist as a letter in the alphabet. And the third obvious class, which we won't be considering, is a scaffold. So if we had a user interface, we'd have to find some way of maintaining the drawing of the scaffold, which would involve adding shapes and seeing whether it was finished at any stage. So we're going to focus on the first 2 classes, and what I want to do now is to look at the attributes or properties of them. So I'll divide this into 2. I'll show the ones I actually thought of when I was first designing the classes, and then I'll talk about the ones I suddenly realized I needed as I was writing the program, and that's always the way these things tend to go. So for the game, I began by thinking, well, we're definitely going to need the word to be guessed, which in our case was ladder, and you also need to know how many guesses you're allowed. And there were a couple of other properties I guessed from, if you'll excuse the pun, from the very beginning. I realized you'd need a property saying whether the game had been won, which you could get by looping over the number of letters which are unfilled, seeing if there are any left. And also a property saying whether the game has been lost, which you could do by seeing if the number of wrong guesses equaled or exceeded the total number of guesses allowed. And then I started programming, and as I was writing this program, I realized we needed a few more. So we needed to maintain a list of the correct guesses and a list of the wrong guesses. Actually, it took me a very long time to realise this, because initially I just had a list of all the guesses with the status for each. And it took me a long time to realise it would be much, much easier to program if I kept them in two separate lists. We also need what the current guess is we're looking at. We need how many guesses there are left at any point, which will be sometimes called a derived property, which we can calculate. And I also found it useful to have a property giving the progress message to display. So that's what comes up in the message box each time you make a guess. Turning our attention now to the guess itself, this was easier. It was fairly obvious that you'd need the letter being guessed. And you also need the status. Now, that wasn't what I thought you needed. When I first began, I just had a Boolean property saying whether the guess was correct or not. But it turned out to be useful to determine whether the guess was a valid guess at all, whether it had been set or not, to be correct or incorrect. So it turned out to be useful to store the status as an enumeration, as we've seen. So let's have a look in a bit more detail about the guess class. Let's suppose you guess D first. That is correct because it's in ladder. Then you guess a Q, which isn't, an X, which isn't, an E, which is, and a C, which isn't. Each of those 5 things is an object based on the guess class. So it has 2 things. It has the letter you guessed and the status of it at the end. So the guess class comprises 2 things, the letter and the status. You could then divide those into wrong and right guesses. So you could take the first guess D, which was correct, and the second guess E, which was correct, and then create 2 or maintain 2 lists. One is a list of the wrong guesses, and the other is a list of the correct guesses. And those are the 2 properties of the game class, which I mentioned much earlier on in this presentation. And it turned out, as I say, to be useful to keep those 2 lists separate. Finally, let's have a look at some methods. So for the game class, it turned out to be useful to have 2 methods. One to actually make a guess, and the second one to show or display on screen the current status message. That's what appears once for each guess as a message box popping up on screen. And for the guess class, what I had initially assumed is it would be useful to have a method to set the current status. It turned out that it was more useful to have the status of a guess as a read-write property. So when you read it, you determine if it's a valid guess. And when you write it, you just set a hidden argument or a hidden attribute within the class itself. That is such an important principle when designing classes. It's so often the case that you can do something by either applying a method to an object or by reading or writing a property. And again, I would stress, there's no right answer to this. In the end, I went for a property because I felt it was a more elegant solution. It's time now to start playing our game. I'm not going to attempt to type in the code. I think this tutorial will go on way too long if I did that. What I'll do is just copy the chunks in, explaining each as I go along. So the first thing we need to do to start the game is to go to line 196 to 207 in the complete code. And what I'm going to do is copy those in and paste them into my hangman example. So this is the code to start playing a game. What it would do is create a new object in the game class and define the word and the number of guesses allowed. And it will create a variable called hangman to refer to that game. So to get this to work, I now need to create that game class. To do that, I can click on the word, press F12 to go to the definition of it. And what I'm going to do is copy down not just the comment at the top and the document string, but also the instantiation routine as well. So if you're keeping track with the line numbers, that's from line 84 to 110. So I'll copy that in. And I need to put that above because I can't refer to a class if I haven't yet defined it. So let's have a look at this class and see what it's actually doing. You need to pass in the self object as you always do with an initial instantiation or initialization routine. The star there is saying, a standard way of saying for any function that all the arguments which follow it have to be declared by name rather than just by position. And that means when I'm creating the class or creating an object based on the class, I need to specify the name of the argument as word and then number of guesses allowed. And the reason I've done that is because I think it makes it clearer when I create a new hangman game if I actually name the arguments. I then specify the two arguments. The first one is the word to be guessed, and the second one is the number of guesses allowed. What I then immediately have to do is to store those two bits of information within the class so that I can refer to them again. So I create two variables with coincidentally the same names to make it easier to read, I guess. And I do one more thing. When I'm storing the word to be guessed, I take the opportunity to convert it to uppercase. I don't really want to force my user to type everything in upper or lower case, so this makes sure that everything I'm testing is always in capitals. I then create three additional variables. The first one for the game is a list of the correct guesses. There aren't any. The second one is a list of the incorrect guesses. Again, there aren't any yet. And finally, I say which my current guess is. So this is going to be a reference to a guess object. It's going to say which guess I'm currently on. And at the beginning, I set that to none. So what I should be able to do now is to run this program. So let's give it a go. If I run that program, it comes up with a message. And then when I choose OK, what will actually happen is the variable referring to the class will be no longer needed. And at some stage, something called the garbage collector will come along and free up the variable and release the memory it's taking up. So it's time now to start guessing letters. And so what I'm going to do is copy lines 208 to 218, copy them to the clipboard and paste them in after I've started my game. And what we're going to do now is to keep trying letters. To do that, we'll display an input box or an input prompt saying guess the next letter. And I've actually converted that into uppercase. I think I might be doing this several times unnecessarily. And then I create a new guess object based on this letter. So we need to create the guess class in a second. What I then do is have a look at the status of that new object. And if it's an invalid guess, then I'll display a message saying it must be a single letter. Now I'm a bit worried when I test this, I'll create an infinite loop. So what I'm going to do is put a break statement in to just make sure that when I test this, it doesn't loop indefinitely. I'll get rid of that at the end. So now I need to create my guess class. And again, I'm going to go back to my original program, click on the word guess and press F12 to go to the definition. And what I can now do is to copy down the comments at the beginning, the document string, and the initialization routine. I'll come back and get the property in a second. So this needs to go above the game class, I think. And that's because the game class is going to refer to the guess. So it's important to put things in the correct order. Because Python's an interpreted language, it basically just reads the instructions down from the top. You can't refer to something until it's been declared. So here's my guess class. As always, it takes in the self, the current object, as the first argument, and the second is the letter being guessed. Letter's actually possibly a poor name for that variable because you might end up typing in a whole string of text. It wouldn't work, it wouldn't be passed as valid, but it would be able to be validated at this stage. What it then does is stores the letter being validated. It converts that to uppercase again. I think I'm overdoing this. And then it sets a hidden attribute, a managed attribute called underscore guess status. So this is something which is considered to be private to the class. And in order to be able to set or get its value, read or write its value, we'll need to write some property, a property decorator. So let's do that now. So going back to my class, I'll select from lines 46 down all the way to 76. And I'll paste that in after my initialization routine for my class here. And this will be what happens when I try to find out if a letter is valid or not. So when I type in a letter in my code down here, what it does is say, is the status invalid or not? That's reading the value of this property. So what that will do if I press F12 in it is go to the get clause, which I've created, and it will run this code. So what this code does is have a look at the managed attribute, the hidden attribute called underscore guess status, which don't forget initially will be set to not yet, because that's what I determined it should be initialized as. And if it's not set yet, it just returns the current status. The reason I put this in is because on subsequent calls to this property, I'll already have determined what the status is of this particular guess. So I don't really want to run through the code again, so it just returns the current value. So from this point onwards, you can assume that you haven't yet determined whether it's a valid guess or not. And this again is a very common code pattern. You have a hidden attribute, a managed attribute, which you initially set to none. And then you check when you read the value of the property whether you've actually previously set the value of that attribute. And if you have, you just return its value without further processing. So what I can now do is say, if the letter or letters that the user typed in at the cursor is none, it means they just press return. So it's definitely an invalid guess. So I'll set that and just return that as a current status. If they typed in either less than or more than one letters, probably more than in this case, it's also an invalid guess. So I'll return that. If it's not a valid letter, then I'll also return an invalid guess. Now this is referencing a module which I haven't yet imported, so I'll do that now. So I need to import the built-in string module. And what the string module does is gives me access to some useful strings. So if I press F12 and that ASCII uppercase, you can see that that's referring to a list of the letters in the alphabet. I could have just typed them in, but it's probably neater to use that. If I get to this point here, then I've got something which is a valid guess, but it still hasn't been set yet. I still need to work out what it is. So I'll just return that and say, instead of being an invalid guess, I just haven't set it yet. So going back now to my code at the bottom where I'm playing my game, for each guess, I'll set the letter to be the next one. I'll create a new object based on that letter or string of letters, and then I'll test whether the status of that is invalid. And if it is invalid, I'll just display a message saying that each guess must be a single letter. And otherwise, I will carry on with my lines of code down here, and I'll actually do something to the guess. But that's coming in the next part of this tutorial. It's time now to determine not just whether your guess was valid, but whether it actually existed in the word we're looking within. To do that, I'm going to copy lines 219 to 222 as shown there, and paste them at the end of my routine. So this is within my while loop. So what I'm doing now is saying, if the guess is invalid, there's no point trying to do anything to it. You just need to tell your user to try again. But if they've typed in a single letter, then what we need to do is process that guess. And to do that, I'm going to call a method called make_guess of the hangman game. But that method doesn't yet exist. So what I'll now do is go to it and copy it. So it's lines 112 to 132. It's a method of the game and not of a guess. So it needs to go within the game class. And I need to make sure it's indented correctly, which at the moment it isn't quite. So what this will do is take in a guess that you've made. So you've dimensioned this argument or specified this argument is an object of type guess. That means it has two properties. It has the letter you're guessing and the status of it. What you can then do is determine whether you've already guessed it. And to do that, you take the letter corresponding to the guess, and you have a look in the concatenated list of all the things you've guessed wrongly and all the things you've guessed correctly. If the letter you've guessed is already in one of those two lists, then you set the status to be already guessed. Now we haven't yet written that status, we've only done the read part of it. You can see that because if you press F12 to go to it, it takes you to the read part, and we need the write part. That won't actually work. So what we need to do is go back to our complete example and find the setter part of the status, lines 77 to 82, and copy that into our guess. So this is going to come after the read part here. And there. So now we've coped with this writing the value of that property. What we can do is consider the alternative case where the letter hasn't already been guessed. And to do that, we have a look whether the letter actually exists within the word. Notice a beautifully concise Python syntax for doing that. And if it does exist in the word, then what we do is mark the status to be correct. And what we'll do is append the letter onto our list of our correct guesses. Otherwise, we mark it as wrong and append it onto the list of the wrong guesses. So that's nice, simple code. And we do one more thing. We say this is the current guess for the game we're currently playing. Now you'll notice at no point at this stage are we trying to draw the letter pattern. So for example, if you guessed D, you want to show __DD__, But we won't do that till we try displaying the message. We won't worry about that. But we have got the raw materials to do it. We've got the two lists of the correct guesses and the wrong guesses, and between them, we'll be able to draw the letter pattern for the word we're guessing. So now if I go back down to where I've written my routine, you can see it should successfully pass the game to the hangman game and determine the status of the letter. Now for each guess, whether you've marked it as having been wrong or correct. What we need to do is actually display a message so that the user knows what to do and can proceed with their next guess. So I'm going to copy lines 235 to 239 and add them on to my end of my loop. You'll notice firstly that I'm keeping in my break command because I want to make sure I don't get an indefinite loop. And secondly, that I missed out up here any test of whether the game was won or lost. I'll do that right at the end. This is calling a method called showStatusMessage, and this is possibly one of the most complicated bits of the routine. So I need to find and copy that in. So I'll go to it, and I'll copy in this. But I'm also going to copy in at this stage a few other properties. So I'm going to copy in the number guesses left property and the current progress property, because I will need those too. And those will be within my game class. So if I go back up to my game class, and if I copy it in at the end there. So what the showStatusMessage does is it takes itself as an argument, because all methods within the class do. That just refers to the current object you're working with, the current hangman game in this case. So what it will do is say, if you've already guessed the letter, then the title of the message, and that's what this variable will hold, is a text saying you've already guessed this letter. You've just made a guess and it's correct. It will display a message saying congratulations, the letter D, for example, does appear in the list. Otherwise, it will display a message saying the letter doesn't appear. So all this block of code does is to set a variable called letterUpdateMessage to be the title of the message displaying the user's success or otherwise. What it then does is creates a variable called MSG to hold a string of text containing the entire message to appear on screen, and it then displays it with the showMessage method at the bottom. The hangman there is just the title of the message box, by the way. So what does this message consist of? Well, firstly, the title saying either you've already guessed the letter, congratulations, you got it right, or sorry, you got it wrong. Then it displays the current progress. Now, the current progress is a property which we've defined just below, which will give us the template for each letter of whether we've got it or not. So let's have a look at that. So what it will do is loop over all the characters in the word, ours is ladder, and for each of these characters, it will add on a space if we're not on the first letter. That just ensures everything's spaced out. And then it will look at the character and say, has it been guessed or not? If it appears in the list of either correct or wrong guesses, then it will add in the letter. Now, I'm pretty certain there's a mistake here, because I'm pretty certain you should just have it appearing in the wrong guesses. There's no point testing for a letter in the word ladder, whether it appears in your list of wrong guesses or not, because it can't, because it was a correct letter. So I think there's a bit of an unnecessary extra test in there, which I hadn't spotted. I hope I'm right. So if each character is one of the correct guesses, then what you'll do is add on to our string of text we're currently displaying the character to be displayed. Otherwise, we'll just add on an underscore. The net effect of this, if we've guessed D so far, will be to build up a string of text like this. We'll start with an underscore, because the first letter doesn't appear in the list of correct guesses. There's no L. Then we'll have a space and another underscore, because the A doesn't appear in the list of correct guesses. Then for the next two Ds, we will find those in the list of correct guesses. And then for the E and the R, we won't. So we'll build out that string of text. And it's often useful when you're coding to write comments like this with examples so you can understand what's actually going on behind the scenes. So that builds up that string of text. And I didn't have to do it in a separate property, but it's quite a neat idea to say that every time you play a game, there's a property called current progress, which you can call it on at any time to give you a template for the word you're trying to guess. So going back to my message, I've now got the success or otherwise. I've got where I'm up to. What it then does is lists out the correct letters and the wrong letters. Space there is just joining the letters together to make them more readable. So it just says if I've already guessed wrongly, for example, Q and X, they will appear as Q space X. So I list out the correct guesses, I list out the wrong guesses, and finally it says how many guesses are left. To find how many guesses are left, this is something, again, I've chosen to put in a separate property. I didn't have to do this again, but I think it's quite neat to say that intrinsically a hangman game has one of the properties of how many guesses you've got left. Each time I call it, I need to recalculate it. And that's what this property is doing down here. It's only got a get side to it. And what it's saying is the number of guesses you've got left equals the number you were originally allowed minus the number of wrong guesses you've made. Hopefully you're beginning to see how you can use read-only properties like this to make code easier to read. It's certainly an art which takes quite a while to acquire. So that completes my message to be displayed on screen. So going back to where I call it, you can see that that would be everything if hangman games lasted infinitely. But I need to now test whether I won or lost. So to test for the end of the game, I'm going to go down to my lines of code from 223 to 235, copy them in, and after I've made a guess, I'll paste them in there. And at this point, I'm going to be brave and change this word break to continue, because if all things work, this will pretty much be the end of the routine. So what's this doing? There's no point testing if you've won or lost, if you guess a letter which you'd already guessed. So this is just avoiding unnecessary processing. So if you guess a T for the second time, there's absolutely no point saying if you won or lost, because nothing will have changed. So what it will do is say, if you've won the game, it will display a message saying, congratulations, you've won. And then the break will make sure that it exits the loop so you don't keep guessing again. And likewise, if you've lost, it will display a commiserations message. And again, it will break to make sure you don't keep offering guesses up. So what I've done is created two new properties of a game. I mentioned this in the presentation much earlier on, called if won and if lost. And what I now need to do, and you've guessed it, is write them. So let's go to each of those two. I'll copy them in. They appear in the other order for some reason. So the lines 179 to 194. And I'll paste them in at the end of my game class. So that will be about here. The line numbers are slightly out of sync for some reason, but it's close. So let's start with the if one. When you call the if one property, again passing in the current object, what it will do, and this is quite clever, is it will create two sets. A set is a set of objects where you cannot possibly have any duplicates in them. So what it will do essentially is take what is essentially a collection of letters, ladder, and create a set out of it. So in this case, using our example again, the word ladder will be mapped onto a set which essentially contains L, A, D, E, and R. There'll be no duplicates. There's also no concept of ordering either, by the way. That's another property of a set. What it will then do is take a second set. Let's suppose I've guessed D, Q, and X. Then the second set will take my letters I've guessed. Let's say I've guessed, so my correct ones are D, and my wrong is, I think I said Q and X. And so what it will do is create a set which contains the letters Q, D, and X. And what it will then do is take the difference between those. So this will find out all the letters which are in the first set, but which aren't in the second. And if you've guessed everything correctly, there won't be any, and so this will return an empty set. Again, I'm not actually convinced I need to put in the wrong guesses there, but I'm going to leave that in because I need to concentrate more than I can at the moment to check that. So it returns a statement determining whether there's any elements in the set of letters in the word you were trying to guess which haven't yet been guessed, essentially. I'm sure I could get rid of that, but I'm still not going to. The if lost property does a much simpler thing. So what it will do is have a look at the number guesses left. I'm actually reusing this. Do you remember I created a property just before which determined how many guesses I've got left? The beauty of this is I don't need to test that because I've done so in a previous case, so I can just assume it's returning what I think it's returning. And so what I can say is if I've still got guesses left, if that's less than or equal to 0, sorry, if I haven't still got guesses left, then I have lost and I need to return true. Otherwise, I'll return false. So then my two properties, if won and if lost, should be set correctly, and I should be in a position to run my program. So it's time now to test the program. Just before we do that, I was correct in what I was saying earlier. I don't need to add the wrong guesses in on that point when I'm testing whether I've won or not, but it won't matter if you do. It won't make any difference. Just slow up the processing slightly. Whenever you're written a complicated system and you want to test it, I would strongly recommend debugging it. And the obvious place to start is where you first create the hangman game. So you can just click in the margin to the left of that to create a breakpoint. If you then press F5 to debug, and if it doesn't work, you'll need to go back to my tutorial on debugging to see why, then what it should do is start running your program. So I'm going to choose to debug the currently active file. So at any point, you've got two choices. You can either press the F10 key or click on this tool to step over a line, or the F11 key to step into it. At this point, I want to see what's going on with my class. So I'm going to press F11 to go into the initialization for that. And to make it clearer, perhaps I should use a toolbar. So this takes me to the initialization of my class. So it's going to determine what the word is. I can let my mouse linger over that and you'll see it's a ladder. And then I can determine how many guesses are allowed. So it's stored the number 5 in there. It's then going to create 2 or 3 blank variables, but they can't possibly go wrong. So what I'm going to do now is press either Shift F11 or click on this tool to step out of it to take me back to my main routine. I can then press F11 to go on to the next line. I know the show message line works, so I'm just going to step over that. And it seems to be running it in several goes. And what that should do is come up with a message to be displayed on screen. Sometimes you have to click on your status bar, or taskbar rather, to see it. It's come up in a separate window because it's what's called a modal dialog box. And then I can choose OK to carry on debugging. So what it's now going to do is display an input box. So I'll press the F10 key to go on to the next line. I'll type in a letter, and let's guess an incorrect letter, so I'll guess a Q. If I press return, you can see it's about to create a new guess based on that letter. If I now press the F11 key, what it would do is go into the initialization routine for the guess, and what it will do is set the letter and the guess status. I can then test whether the guess status is invalid guess. Now this is a read property with some code attached to it. So when I press the F11 key, what it would take me to is the read part of that property, and it will determine whether it's an invalid guess or not. So I can step through that, and I can say if the length of the letter is not equal to 1, well it is, and if it's not a letter, well it is. So we'll return the status not set yet. And because of that, it will bypass the message which would have otherwise appeared saying each guess must be a single letter, and go on to actually pass this guess into the hangman game. So then I can press F11 to go into that. And what this will now do is see whether the letter I've typed in is one of the incorrect or wrong guesses. Now, if you look at those two variables, I think they're both blank at the moment because I haven't guessed anything. So when I press F11, I would expect it to go straight onto the else clause of that condition. It's going to see whether the letter already exists in the word. Well, it doesn't because it was a Q. So we'll jump to the else clause and set the status to be wrong using the right part of my property. And then we'll append that onto my list of wrong guesses. So if you now look at the list of wrong guesses, you'll see it contains a single entity, which is the letter Q. Now what I could do is now carry on like this, but I think you've probably got the idea. So I'm going to go for it. I'm going to click on the play tool or press F5 to see if it works. So it says that the letter Q doesn't appear, lists out the correct and incorrect letters and tell me how many guesses I've got left. If I choose OK, I'm going to go for a letter L now because I think that's going to be a good one. And you could, if you like, now test it out. I have done, and I'm pretty confident it works. At some point, in my case when I've won, it will jump out the loop and display a final message, which I haven't actually copied in. So for the sake of completeness, I'm doing exactly the same thing in my original program and my final one. Let's just copy the end thoughts in to the end of this. And Now when I run my program, I'll get a message pointing out that you could have done this in many different ways, and it's absolutely not the case that the way I chose was the best one. But one of the worrying things about classes is I'll never actually know which the best one was. It's not like something like relational database design when you pretty much there's only one correct way to do it. With classes, there's lots of different approaches you can take, and you never quite know if yours was the most elegant one or not. So I hope you've enjoyed that Hangman case study, and I wish you joy in programming classes.